Welcome to this training video on how to use the Balluff HF/LF application for the RFID handheld series BIS V830. This application is designed to be used with BIS-M, BIS-L and BIS-C read-write heads and data carriers. Also, the integrated NFC antenna of the handheld can be addressed with this app. The reading of 1D and 2D visual codes is possible as well by using the camera. Let's have a look at the structure of the app. The app's RFID mode with the read-write buttons is located in the bottom navigation bar. You can switch to the mode of reading visual codes by using the scan symbol in the bottom left. Under More, you can access the settings. Before the app can be used, it must be ensured that the basic device has established a connection to the plugin module and the read-write head. This is displayed below the read-write buttons. Currently, there is a connection to the integrated NFC antenna. If a module with a read-write head is plugged in, the designation of the read-write head appears. Then the handheld is ready for use. The read settings are located in the top navigation bar. The currently used template is listed here. In delivery state, you can choose between the two preset templates, hex and ASCII. By specifying the address and the length, you can select the area of the data carrier to be read. The read data is then displayed in the main screen. The application has a user management consisting of 3 roles: user, expert and admin. The user roles can be changed under More. The user can only read and display data. The expert can read data, but also edit data and write it back to the data carrier. The admin has permission to all app functions, especially the creation of templates. The default passwords can be found in the manual. To change the password, you must be logged in as an admin. Then the passwords for expert and admin can be changed. Let's have a look at the RFID mode. The read command is started by using the read button. A continuous read is carried out. If no data carrier is found, the read command aborts after 30 seconds. The read command can also be cancelled by the operator himself. If a data carrier is found, this will be visible in the progress bar. Depending on the size of the data carrier, the read command takes different amounts of time. The entire data carrier is currently being read from byte 0 to byte max. The data is output in hex because we chose this template. The tag metadata shows the UID of the data carrier as well as the Balluff tag type and the user memory. In the other blocks, the user data is being displayed. The read settings can be changed individually. It is possible to set the display area to start at byte 8 and show the length 24 bytes. At the moment, the write button is grayed out because we are logged in as a user and do not have permission to write. That's why we now change the user role. Now the write button is still gray because a field needs to be marked as to be written. It is intended to only write the selected fields. This avoids errors so as not to overwrite anything that was not planned to be overwritten. Also, it keeps the process of writing as short as possible. Nevertheless, it is possible to mark all fields for writing. This feature is located in the top bar under the 3 dots. All fields can also be unmarked here. To edit data, click into the Data field. The keyboard automatically pops up. The app shows which byte is currently being worked on. When editing data, the field is automatically marked for writing. Before the writing process, the security query appears to avoid accidental writing. During the writing process, the data carrier must be in the active area of the read-write head. Try to get as close as possible to the data carrier and hold the read-write head as still as possible. Pay attention to the progress bar to determine whether the write command has been completed. There are further additional functions under the 3 dots in the top bar. With clear tag, for example, the entire data carrier can be overwritten with any hex value. By clicking Write, the data carrier is overwritten. Here you can see the progress bar during the writing process. Furthermore, the data carrier can be saved. This function can be useful if data carriers need to be reset to a certain state. You can find the saved data carrier in the list underneath the More menu. It is also possible to export the data carrier in the format JSON. The export file can be stored under Total Commander and then in the internal memory of the device. Also, it could be stored on a USB stick. Therefore, the handheld needs to be placed in the charging cradle and a USB stick needs to be inserted into the charging cradle. So far, we have looked at the basic functions of the app. However, the special feature of this app is the high flexibility and the option to individually customize it. And this works with the template function. Remember to be logged in as admin for this function. We will now create a new template. First, we will assign a name for this template. The display of metadata can be switched on and off. For BIS-C, please always switch it off. We are currently working with a BIS-M system and that's why we will switch it on. The display of the byte address can also be switched on and off. Now we start to rebuild the data carrier structure and the data mapping. In a template there are sections and data fields. Sections are only used to group certain areas of data. They are basically headings for better visualization. Data fields are the content of the data carrier. We now give a name to the section and start with the first data field. The available decoding types are ASCII, hex, BCD, 1 byte as binary, signed and unsigned integer and floating point. Enter a start byte and a length. New data fields can be added with a plus. Let's set up another data field. It is not necessary to display the whole data carrier. There can be gaps between several bytes, like here between byte 20 and 36. This makes sense if the operator is only supposed to make changes to certain areas. Then only these areas will be displayed. Click Save and return to the RFID display. The customized template can now be found in the top bar in the Read settings. We have previously cleared the data carrier with the hexadecimal value FF, so there is no useful information here. But we have prepared another data carrier with useful tool ID information. We will now read this one. And here you can see useful information. And we also prepared the example template 1 in advance of this video, and this fits perfectly with the content of this tool ID data carrier. All functions like reading, editing, writing, and the special functions work exactly the same in the preset templates and in the self-created and customized templates. Let's move on to the function of visual code reading in the bottom left. By holding the visual code in front of the camera, the reading automatically starts. The red codes are listed in the white area. It is indicated what kind of visual code was scanned. Also, the number of bytes and the content of the visual code are displayed. The scanned code can be copied into a template. The transfer of a visual code on the RFID data carrier works in the preset and in the customized templates. Let's have a look how it works with the preset templates first. By clicking on the scanned code, this code is selected for the RFID transfer. It is entered in the template that was active at the last use. The scanned code is entered from the byte that is currently set on the read settings. Here it is byte 0. Any other starting point is possible as well. Let's try to insert the code at another byte. Now it is inserted at byte 80. The scanned code can also be transferred to a customized template. To do this, there needs to be a data field in the template with the length of the scanned code, which is 9 bytes in this case. Let's go into the customized template 2 to set in a data field for the visual code. Save the changes and head back to the RFID mode. When reading now, there is no information on the data carrier at byte 80. That's where we will now insert the data matrix content. Choose the code in the scanned code list and then choose the data field where the data matrix code should be inserted. It is now inserted, and to write the information on the data carrier, click Write. Now the visual code content is successfully copied into the data carrier. These are the most important functions of the app. Several adjustments can be taken under Settings. With BIS-C, it is absolutely necessary to select the data carrier used to make sure it is read and written correctly. Also, the About dialog and the Terms and Conditions can be found here. And in the unlikely case that you want to use another application, you can exit the application here. Thank you very much for watching and have fun with our flexible handheld family and the HFLF app.